Okay, I think we're there. Okay, thank you all for joining today. It's a pleasure to see you all. I know that everyone got to DevRocks yesterday, so thanks for making it today as well. I just wanted to start with a quick poll. So everyone who is working on Kubernetes now, could you raise your hand, please? Okay, yeah, that's good. That's everyone. Great. Everyone who's ever faced any autoscaling issue or tried to implement any type of autoscaling, can you raise your hand? Okay, great. And just one final question. Anyone who's ever heard of Keda, can you raise your hand? Okay, great. Then we have a good audience today. So thanks for joining the talk today. It's about how to save millions over years using Keda. So let's just start with a bit about me. So I'm a software engineer at BlackRock. I've been there for the past 3 years. I've been a speaker at DevOps last year also, and I'm generally passionate about new technology, cybersecurity, and cloud. So today we're going to cover first our use case. So where and how are we going to try and save millions over years with Keda? Then we'll cover the alternate options that we had. Moving on to the presentation of Keda, because not everyone raised their hand today. Then we'll have a look at the Prometheus killer, the Keda setup, and finally coming to the money part, the interesting part, I guess. So we're just going to start with a demo of Aladdin Compute, which is the main product that I want to demo today and the one that we are going to be working on. So let me just try by creating 2 sessions here. Yeah, I know this is directly from Postman. The UI is not there yet, but you're going to see it's still going to work well. So now if I go to the UI here of Aladdin Compute, we can see the 2 sessions that we just created here. They are loading up. So in the meantime, we're going to have a look at the session that I created before the talk. So it's Aladdin. So it's this online IDE that we have. So mainly, what is Aladdin Compute? So Aladdin Compute is a project that we have within BlackRock. For those who don't know BlackRock, it's the company that I worked for, and it's mainly an asset manager, meaning that we have this product, Aladdin, that we are selling to other asset managers to help them with their day-to-day work. So we have a lot of trading, we have portfolio management, and we have a lot of different things embedded in. But we have a lot of clients that want a lot of different things always added on top of it, of the features that we're already offering. So this is why we decided to create Aladdin Compute, which is mainly a way for our client to build on top of us and access our APIs and our data from this workplace. So it's online ID. So this is a notebook that we can have a look at. This is just to run the code. So we are giving our users a lot of our APIs so that they can mainly build on top of us. It's the main idea. So if we run this one, for example, so we can see here all the API names that we want. For that one, for example, we can see for the Aladdin order API here, we can see the endpoint that we have. And later in this notebook, we can see the Aladdin Data Cloud. So it is mainly our in-house data storage, and here you can access the data. So mainly we have this online ID. So now what do we have? So we have users that are going to come on our platform, and they're going to create a session which is going to provide them with this online ID where they can build whatever they want and they can run their code. So now if we open one of the sessions that we created, so this one is the one that we just created. And yes, we trust me. We're just going to run a very small piece of code here, which is mainly going to simulate an infinite loop. We just want this notebook to be very busy. That's the main idea. So we're just going to select our Python environment. There we go. And as you can see, so in this notebook, you can run whatever Python code that you want. It is collecting right now. Did it finish? No, it's still running. And so if we move fast forward while this is loading, so the main issue that we're facing with our sessions right now is that we have users that are going to come on our platform, they're going to create their session, they're going to run their bit of code, do their bit of work, and then they're going to leave the session open. They're never going to close it, they're never going to delete it, and it is going to cost us resources because we created it in Kubernetes, we assigned resources to it, and then we never have the user shutting it down. So it's just for us a bit costly. So here, yeah, this is simulation of infinite loop. It's actually trying to break a hash, but it's not going to break it in the time of the session. So now moving on to the alternate option that we had. So our idea was that we want to be able to shut down the sessions not when the user shuts down the session, because we just saw that the user are not very naturally going to want to do this. So we're going to actually shut down the session when they are idle. So how do we do this? So our first option was to have Hades, so the god of death in ancient Greek. And what did Hades do? So Hades is a tool that we implemented, and Hades is mainly going to shut down all the sessions on the weekend. It's not very user-friendly. It means that our user that came created a session, and he did a bit of work, and then on the weekend, we're going to kill his session because we actually can't really afford to have that many sessions running. And then he comes back on the Monday, and he has to start again from scratch. So it's not the most convenient thing to do. So that's why we decided to move on and have Pluto, which is also the god of death, but this one is in Roman. And what did we decide to do with Pluto? So we decided to have a whole dedicated server which would go have a look at the sessions and determine when they're idle or not and shut them if it says they're idle. But both of those options were not that good. So the first one just kills everyone, doesn't care about if you're using it or not on the weekend, and it's not that good. The second one is better, but then it's like meaning we have to support a whole new server, a server that's dedicated to shutting down idle sessions. So it's still a bit complicated. We had other alternate options. So we had the Kubernetes HPA, so just a little poll. Who knows about the HPA in Kubernetes? Yeah, everyone who already used it, actually. Okay, we lost a bit of people, but still we have some people keeping up. So the issue that we had with the Kubernetes HPA is that it's going to do the scaling, but not on, it's just going to do the scaling on some very specific fields. So we have, for example, it can scale on memory or on GPU utilization, but for us it was too broad and we needed something more specific. So this is why we actually found Keda. So Keda, it stands for Kubernetes Event-Driven Autoscaling. And what is very good with Keda, let me introduce you to a few of the key features, is that it supports multiple event sources. So the difference with the HPA is that mainly it is not going to be only able to scale on memory or CPU utilization. It can scale on a lot of scalars. At the moment, I think that there are about 60 scalars at least, I think 64 if I'm being precise. For example, it includes Elasticsearch, it includes Prometheus, it includes RabbitMQ, and a lot of others. The integration with Kubernetes is seamless, so was way better for us because we don't have to create a whole new server, and then it was going to help us to do more efficient resources utilization. Instead of giving a lot of resources to a session that's not going to be used, then we were able to then shut it down. So now we're going to do a little bit of a demo of Keda. So let me show you here. So we are in my, why is it there? Okay, can you? Yeah, we can see. So now we're going to go in my rancher, in my rancher context. So now we are going to actually install Keda. How is it complicated? Can you actually see? Let me just, get that bigger. We're getting there. Okay. So we are going to install Keda. So it's going to have everything. So as we can see, it took around 5 seconds, which is what we want. Now we are going to just create a little deployment. So this is, I think, the most basic deployment that you can have. It just takes the NGX image. So if we have a look at the deployments, it's starting up. I had a look. It takes around 10 seconds to start everyone up. Yeah, so now we're getting starting. Now we're going to have a look at a scaled object. So if we go and look at a scaled object example that we have, so this one that we're going to do is going to use Prometheus because it's the one thing that for us was easier to do. So we just have a bit of authentication to reach out to our Prometheus locally. And there we can see that we're going to go between 0 and 10. And what is important here is the query. So I got asked once, why is there bool in the middle? I actually don't really know. It's the Prometheus query language. I don't really get it all. I just know that it works. So if we look at this query, we can go and have a look at the query directly in Prometheus here. So we're going to run this query. We can see that it's 0 all the time. So meaning that if I apply this to my deployment, as we can see here, it should just scale it to 0 because it doesn't get any answer. So now we're going to apply this. So now we applied the scaled object to our deployment directly. We saw that the trigger was a Prometheus query, which returned 0. So now if we look at the deployment, we can see that it actually scaled down to 0, which is perfect because it's exactly what we wanted to see. So this is the main highlight of how Keda works for those of you who did not know about it. So now we are going to want to apply this to our session problem from the beginning. So we are still going to keep using the Prometheus scaler because it works well. It's already integrated in the company, so that's really good. How are we going to do this? We're going to do a little demo of Prometheus. So remember, we have sessions that are here, that are generated, and we want to know when this is going to be idle. Mainly, we want to know when the user is not here anymore. This is what matters for us. So what we did is that, so we provide, as you can see here, we provide Jupyter IDE or we provide a VS Code Online IDE. So we actually developed a little extension. So this one that is going to actually just export metrics. So yeah, let me just give a bit of credit to someone because I developed that one. As we can see here, it's my name. Yeah, so I mainly got a lot of inspiration from that person that actually very nicely put it their extension, open source, but the main difference is that it did not work on online IDE. That's why I had to do it again, especially for the online IDE, but still want to give credit. And if one day I do this speech and this guy is actually in the room, please can he raise his hand? Doesn't look like he's here today. So now we're just going to have a look. So it's the session that we created earlier. As we can see, it's still running. And now we can have a look directly in our, we can have a look directly in Grafana, which retrieves the data from Prometheus, and see if our metrics are actually getting exposed. So let's have a look. And we can see that it's here. It's getting there. So we can see that we have it for only one pod for now, so we have it only for this session that you can, I hope you can see here, it's KWTV. We can check if it's actually the one, KWTV, it's actually the one that we opened. The other one, we can't see it because it never started emitting data, because we never opened it. So for now, it's still on 0, but it should go on to 1 because we are actually using it. Now we are going to have a look at the triggers and the scaled object that we are going to want to define for it. So we have our session. We have our session that is not idle, that is being used. And we want to have a look what kind of scaled object can we create so that we are going to retrieve those metrics, and then we're going to actually have a look at them. So let me just show you from here. So this is an example of the scaled object that we created for the session. So that's great when it's big like this. So here you can see that we have our server address, which is our dedicated Prometheus, and then we have our metrics. So we have two of them, one here and then one here. So idle threshold and idle session. So as we saw, when we don't open the session, it never starts to emit data. So if you go a bit further in this, it means that you're going to create a session. Your session is not going to emit data because you haven't opened it yet. But if I have then a trigger that is going to shut down when there is no data, it means that I can never open it because then I'm going to create it. It's going to get killed because it doesn't have data. So it means that I have an issue because I can never create it. So that's why we decided to go for two metrics. So one that is going to actually go here. So that one is going to get the data. So as we saw, the terminal's active, and this one is going to have a look at the notebook active, and it's going to be dedicated for that. But we also have this second one, so the second trigger, that is actually going to be a function of time, meaning that when I create my deployment, I am going to give the user something like 60 minutes to actually go open the online IDE so that it will start emitting data and it won't get killed directly. It's also going to be very useful when we want to restart a session, meaning that you were on your session, you did some work, then it got idle, so we shut it down, we scaled the deployment to 0, but now you want to restart it. So how could we do it? Because you're not going to emit data, then we are going to use also this second trigger, and we are going to change mainly the value of the current Unix time so that it will just give you 60 more minutes to go and actually open it. So now we are going to talk a bit more about the setup for Aladdin Compute. So as we had a look in the Keda demonstration, it is actually really easy for us to install it in the cluster. Then we do the scaled object definition. We have to identify what we need, what we don't need. And then we do our little scaled object triggers, knowing about everything that is possible with Keda. So what is it now to set up Keda in Aladdin Compute? Meaning in a larger company, it's not my local host anymore. So there are a few challenges that we faced, which are mainly regarding to big companies' problem, I would say. So we have, first we have many layers of authorization. So I can't just push something in the cluster for everyone. So it requires a lot of understanding, actually really deep understanding of the Keda files and what they are about and what is written in that code. Because the Keda file, if we have a small look at it here. So if we have a very small look at the Keda file, it is extremely, extremely, extremely long. It's actually, I'm not going to go all the way down. It's 10,000 lines. So I needed to understand what were in those 10,000 lines so I could convince my company that nothing there was bad and that we could go for it. It was not going to hack our data or anything. And all of this work actually takes time. So if we have a little bit of a look at some parts of the Keda code, we are going to look at some issues that we may face. For example, here, it's actually going to access resources directly in the kube system namespace, which is very high up and which can be a bit scary when you are a company and you want to make sure that this new tool that you're onboarding is not going to do anything with you, it's not going to shut down everyone all the time. If we also have a little look at this extract that I got, so this is a cluster role that we have. And there are some little issues, some things that we could call red flags, actually. So in this little example that I'm showing, we can have one of the red flags, which is around here. It's that Keda is asking for access to all your secrets. Why does it want that? It's mainly for authentication purposes, so it's actually good. It's so that you can use it more easily. You can put secrets, then it's going to read them, going to do authorization. But in a bigger company, you can't really have resources that's authorized to go and look at all your secrets. Also, it's going to ask for access and all permissions to your config maps. Same thing again, you don't really want an external thing that you downloaded for internet somewhere to go and take all your config cards, all your config maps, and finally we have the wildcard, and the wildcard is not the thing that we like the more. We like to give the minimum permissions to every resources. So how did we do it? So we still, like, with a lot of discussion, we managed to find in-betweens, and we managed to actually get things done. So how did we do for the access to all secrets? It's actually, Keda is really well made. It actually can go to a HashiCorp Vault. So we just removed the access to all secrets, we put all our secrets in HashiCorp Vault, and then we gave the access from Keda to this very specific section of HashiCorp Vault. Then we reduced the permissions, not to all config maps. We identified the ones that were actually going to be useful, and we only gave that access. And for the wildcards, we tried as much as possible to reduce the scope of the wildcards. So now let's have a look at the demo of the sessions auto shutdown. So as I told you from the very beginning, the whole point is that we want the session to shut down when it's idle. So now if we go back here and we go back to our sessions, we can see that we still have our 2 sessions there. And if we go here and we have a look directly in our cluster, so let me just change context. And now we're going to look at the deployments. We can see, so this is the first deployment. This is the one that we actually started, it started emitting data. This one is doing really well. And the other one is the one we never actually opened. And we can see that they are both 19 minutes old, and we put a trigger on 10 minutes. I see some people struggling to see. Maybe it's better like this? OK, great. And we can see that it got shut down to 0, so it got scaled to 0. So this is exactly what we wanted, and we can have a look in Prometheus again and look at the data here. OK, so, oh yeah, I'm looking at the active terminals, but did we open a terminal? I don't think we did. Let's go more and look at the notebook actives. And here we can see that the notebook is very active, which means that we don't shut down that session. The other session that never emitted any data, that's why it's going to get shut down. Now, if we want, we can also have a look at how we restart the session. So this one that we see here is actually the one that is not working anymore, but we can restart it from here. So as I mentioned before, we are going to go and change our value in one of our trigger. And now if we go back and look at the deployments, OK, did not get it right now, but we can go and have a look at the scaled objects. So if we go and describe one of our scaled objects, we're going to describe this one. Oh, yeah. So something was off. So here we can see that it deactivated the session from 1 to 0. We can see that it's still happy because it's still able to go and look at all the triggers. And as we did not set up any fallbacks, it can't go and it doesn't have a backup solution. And here we can see our query that is there. So that's our first query, the one that involves the terminal active, the one that involves the notebook active. And the second one there is the one that involves the time. So now, conscious of time, let's do a small recap. So if we got it right from here, we have users that are going to create sessions, and we are going in Kubernetes to allocate resources. We are going to create a session, and we are going to give it some GPU and memory. Then we are going to have our users that are going to stop using the session and that are not going to shut them down or to delete them, because that's just not a very natural user thing to do. And then we have us that want to shut down those sessions because we don't want to actually have this cost for us. So we are going now to move on to a very interesting question, is how much money did we actually save? Because that's why we're here, right? So interestingly enough, we saved 0. So all this work and everything else is great, but we did not save money. And why is that? It's mainly, first thing, is because of the Azure billing models. So mainly, we are a big company. We want to make sure our resources are available all the time when we need them. So we don't pay Azure as we go. We need the resources to be there all the time. So we are paying 3-year savings plan, meaning that we pay for the resources 3 years ahead. So if right now we stop consuming anything, we don't save anything, it's already paid. But it still stays very important. If we do a simulation now of if we were paying as you go, which is where we should head in a couple of time when we get more confident with the usage of the cloud. So if we look at the average price per VM, it was actually very interesting for me to go on this. So this is an extract of the Azure billing prices, and it's extremely confusing place. The prices go from $25,000 a month to $1.7 a month, depending on what kind of VM you want. So for us, we're going to say that the average price is around like $1,400 because this is the kind of VM that we are more likely going to use. Then we're going to have a look now at the average consumption of a compute session. So this is also, once again, a bit of a confusing place with very, very varying things. So we can have sessions that are going to need 30 CPUs, 16 GB of memory, and we have sessions that are going to need 2 millions of CPU and very, very few memory. So here again, we're going to take an average value so that we can move on, do some calculation, and calculate how much we could save. But just keep in mind that those values are average, which is not maybe the best way to do because it's just very broad scales. So if we take the average of everything, we're going to have 3 GB of memory and around 0.1 CPU. So now we're going to do a simulation on the savings, so with Keda and without Keda. So we have around 3,000 users actually, and we have sessions that are actually idle for around 60% of the time. So if we have Keda, we are going to have only around 1,200 active sessions, whereas without Keda, we're still on 3,000 active sessions. So the average consumption is the things that we just defined previously. And now we're going to see the average price per month for this session. So it comes around to $8 with the average that we took, the average values that we took before, leading us to a total cost per month, so without Keda, of $25,000 and $10,000 with Keda. And then meaning that the total cost per year is like following. And it means that if we want to save $1 million, knowing that we are going to save around $180,000 a year, it's going to take us around 5 years. As we said before, we pay our resources 3 years ahead. So it means that we are going to need a bit of some loops before we start actually saving money. But the cost savings that we can do are still really important. But why is it still interesting to do this now? Because in a company, when you're talking them about in 5 years, we may be doing something, they don't get as excited as you would want them to be excited. But why is it still interesting for us to do this right now? It's because then we can support more users actually at the same time, meaning that if we're able to allocate resources differently, we will support more users, because if this user is actually not there, we can give its resources to another user. It's also going to improve our efficiency for obvious reasons. Then, like, if we have less users that are having resources used like for nothing, then we can guarantee more resources for other people. And we'll still save money when we reevaluate in 3 years if we're able to prove that we actually need way less. So in summary, I would say that Keda and Prometheus are excellent tools. They are very easy to use, they're very easy to download, and they are open source. Then we are going to have, on top of like having cost reduction. We also have resources optimization and a better user experience overall. So yeah, just wanted to do a big thanks to everyone who helped me for this talk. So it's my users, my manager, my previous manager, and my team generally. If there is any question, we can get them now, but I think we only have 1 minute. So if you want to find me anywhere during the conference, if you're still sticking around for some time, it'd be my pleasure to talk to you. Thank you.